Okay, so now we are on study unit 1, airplanes and aerodynamics. So we'll go through this. So what is an airfoil? Coop, you want to read what an airfoil is? I am on page 19. Page 19, 1-1, airfoils.
Any surface designed to obtain a desired reaction force, i.e. lift. When in motion relative to the surrounding air, an airplane wing and a propeller blade are examples of an airfoil. The diagram below shows some common airfoils.
Okay. So there's some different kinds of airfoils there that they show in the book. Some of those are designed to be more for high speed, some are low speed. If you go out and you look at the wing of a Piper Cub, it's a very thick wing. If you go out and look at these jets, it's probably thinner than the Piper Cub. They both create lift, but the Piper Cub's getting off the ground at 30 miles an hour or less. Mm-hmm. And this thing, you're looking at 80 or 90 knots, so almost 100 miles an hour before it's about ready to climb out. So there's different kinds. But on the test, what they're going to ask you about is some different parts of the wing. All right. So up here, I've drawn a really nice wing, and you can almost even see it on the internet. All right. So this is going to be our leading edge. Here's our trailing edge. Now, if we have a line between those two, almost. I'm not an artist. I fly airplanes. The line between those two is going to be your chord line. Okay? So that's something you're going to want to remember. So you're going to want to highlight these different parts. All right, so the upper curve is the upper camber, and this is the lower camber. And then, like I said, between the line directly between those two is the chord line. We talked about that. Now, angle of attack. You hear a lot about angle of attack. So let's talk what that is. Normally, when you're flying straight ahead, your what do they call it? The relative wind is going to kind of look like this. So the angle between the chord line and the relative wind, that is your angle of attack. Okay? So right here, flying level, how much of an angle do we have here? Really not much of an angle at all. So that'd be a low angle of attack. Okay? Now, if you were powered back and you're coming down and now the aircraft is kind of moving in this direction, that would be a higher angle of attack. All right, are you following me? Okay, so that is the angle of attack. So if you see that definition in there, it should be under number 2 on aerodynamics, angle of attack. The angle between the chord line of the wing and the relative wind. The relative wind is parallel to the flight path. The angle of attack is based on the flight path, not the ground. Okay, so you can be climbing and have a 0 angle of attack because you can be going straight up and have a 0 angle of attack. It doesn't have anything to do with the ground. It's the relative wind. Okay. Now, angle of incidence. I don't think they ask you about this, but let's talk about it. If you look at the picture there, do you have this picture somewhere? Mm-hmm. Yep, right there. Okay. Yeah, the book's a little different. Okay. Usually, if you look at the airplane overall, the wing has a huge wing on that airplane, but deal with it. The wing has usually got a little bit of a tip up to it. Okay. So the difference between, somebody want to read it? Angle is the angle formed by the chord line of the wing and the longitudinal axis of the aircraft. So we're going to talk about longitudinal axis here in just a minute. But that is your angle of incidence, the difference between the chord line and the longitudinal axis of the aircraft. The attitude is the relationship of the airplane to the horizon. So it's pitch angle. So nose up or down is pitch. Okay, center of gravity. That is the point about which an airplane would balance if it were possible to suspend it at that point. So usually the center of gravity is, in light aircraft, it's usually right between the two front occupants. That's where the center of gravity. So when you go to a turn or you bank, you pitch up and down, it revolves around that point in the aircraft. If you put somebody in the back seat, the center of gravity is going to move back. So now it's going to revolve a little bit about that. So when you're sitting there in the plane, usually the people in the back seat get sick first because they're the ones that are wobbling around up there, and you're just turning like this. But now they've got all that movement, kind of like sitting in the back of a bus. You know, the bus turns the corner, you go flinging around if you're in the back of the bus because it really swings you around. Well, the same thing happens with an airplane.
So let me ask you a question.
Yes, sir.
So basically, when the CG moves backwards, let's say, for example, the fuel fills over the wing, so it stays balanced. But you throw stuff in the back, you throw a passenger in the back, and now if it's just you and I flying empty, so the CG moves back away. So when you go to take off, the only differences it makes is technically when you trim out, you trim it so that it keeps you level, because otherwise, if they would just jump out, then it would automatically want to go like this.
If you lost your backseat passenger,
right? That's what I'm saying.
Yeah. Well, you're getting ahead of the class.
Okay,
you're getting ahead of the class.
Okay. I'm just thinking
we're going to talk about weight and balance. And,
yeah.
And so this wing lifts this way. The horizontal stabilizer down there is an upside down wing, and it goes that way. Right? So there's a balancing act when you move stuff around as to how much downforce this needs versus how much lift you got to have there, and so we'll talk all about that. There's even going to be math involved. So the center pressure, the point along the chord line of a wing at which all the aerodynamic forces, including lift, are considered to be concentrated. For this purpose, it's also called the center of lift. Right? So I kind of drew it here. Here's our center of lift on that wing. All right. Dihedral. You ever look at the front of an airplane, you can see that the wings are kind of up. Yeah. F4 Corsair there.
Love that plane.
Has a lot of dihedral on the outside, and then.
How come not many planes are? We were talking about that. That was about the only thing that ever come out like that.
There was a couple, but the other ones are really obscure.
Yeah.
There's not much known about them. But the dihedral there is the angle at which the wings are slanted upward from the root to the wingtip. That's dihedral. Relative wind, the direction or airflow produced by an object moving through the air. So you ever stick your hand out the car window? Of course you do. We do it all the time, right? So the relative wind is that how your hand's moving through the air. You can be going up a hill and you still kind of feel the same relative wind, right? It doesn't change just because you went up a hill, or you can be going down a hill. It doesn't change. So the relative wind kind of stays the same. Then when you tilt your hand up, you're opening up that angle of attack, right? When you tilt your hand down, you're lowering the angle of attack, but you can also go negative, right? Because now you've got pressure on the top here. All right. So page 21. Is everybody there? Do you have this picture? Mm-hmm. Okay, cool. Yeah, so just kind of what I was just saying. Whether you're with your hand out the car window going up or down, the relative wind kind of stays the same, but you can change the angle of attack of your hand. Let's go to the next page. Stall. So the stall is a loss of lift and an increase in drag that occur when the aircraft is flown at a high angle of attack, greater than the angle for maximum lift. Okay. So we're not talking about the engine stalling out. That's completely different. We're talking about after you've increased the angle of attack so much, now there's no longer a smooth flow of air over the wing. Okay, so let me find my eraser. We'll talk about this, and then we're going to watch a video. All right, in order for a wing to create lift, I might be getting a little out of us here. What they did was they took a tube. Back up here. They took a tube and they pinched it. And they forced air to go through that tube. And they measured the pressure and the speed at these three locations. Okay? So, PS. At this location, the pressure was high. And the speed was slow. Okay? So we've got high pressure, slow airspeed. When it forced its way in here, the pressure went low, but the speed went high. Okay? And as it exited, the pressure went back up and the speed went back down. Okay? So those are my gauges. Look pretty nice, don't they? So what they figured out was that you can create this low pressure in the middle as the fluid, right, water or air, accelerated and had to go through that squeeze part. And if we take a look here, you still have that curvature, even though I erased part of it. All right, what do we have there? A wing, right? So as the air molecules hit this guy, on a relative wind, right? Some of it has to go over the top. It has to go a long distance. Some of it goes underneath. It has to go a short distance. So this stuff, if it's going faster, the pressure is
Lower.
right? So there's a big low pressure that sits on top of that wing. And there's a high pressure that sits on the bottom. So what happens is when you get enough low pressure on top, basically the airplane gets sucked off the ground. That's part of it. The other part is you have air bouncing off the bottom of that and the aircraft. So
Would that be called float?
well, there's a word for it, and we'll get there. I kind of got ahead of us there, but it was the right time. So let's talk about that stall. That's where I was going with all this. So you got to have that smooth airflow over the wing in order to produce lift. All right, and right now our angle of attack is very low. So here's our chord line from the leading edge to the trailing edge. So our angle of attack is pretty low. We have this nice smooth airflow going over the wing. All right. Now what happens if we increase that angle of attack? We still got to have air going over the top. What happens is it starts to spill. It starts to eddy and backwash back here. So it's not that smooth airflow. Now you still have this, but as this angle of attack increases, you lose the lift of the aircraft. And after you lose so much lift, the wing will stall. Okay? So we're going to watch a video on what a stall looks like, and then we'll get back into it. Which one was which? All right. Anybody live streaming? We got to cut you off. We'll be back.